Hi, Geometry. As you can tell, I'm gone today. Thought it would be easier to present the lesson with a video. If you have any questions, I'll be back tomorrow. You feel free to ask then, but hopefully not too tough of a section for you. I'll go through it here, but I'll leave you with a joke at the end. What did the green grape say to the purple grape? You'll have to wait at the end to see what he said. Go ahead, find the value of M here. This is your bell ringer. I know I picked them up last week, so go ahead, put these on a new sheet of paper. Hit pause now, and go ahead, do these. When you're done, hit play. Hopefully you took time to do these real quick. Basically what you have is slope equation here. It's usually y2 minus y1 over x2 minus x1, so they plug in different numbers here. Notice first one you get 2/5. Second one's negative 3/2. 3/4 might be one people usually miss. If 0 is on the bottom of the fraction, it's undefined. You cannot divide by 0. However, if 0 is in the top, like number 4, then you have 0. So this is a key point to note. A lot of times students miss this. Again, 0 in the bottom of the fraction is undefined. Top of the fraction is 0. Go ahead, put these away, and I'll go through the notes here. This section deals with slopes of lines. Should be real familiar with this with Algebra 1. A lot of time was spent on finding slope of a line. From there, we're going to use slope to tell if the lines are parallel or perpendicular. Not much for the vocab in this section. You got rise, run, and slope. Basically, slope is how steep a line is. It can be negative, it can be positive, it could be 0, or it can be undefined. And to find this, you take 2 points, and then you can determine the slope. Here you can see an example of finding slope. Rise is the vertical change, so here you can see it with the blue. This is the rise going from this point. Run is how you're going from left to right or horizontal. This is the run. And to find the slope, it's rise over run. So here you see 6/4 and reduce that down to 3/2. Rise over run works really well if you have a graph. You just count how many you go up or down over how many you go left or right, and you get the slope. If you have 2 points, the slope equation is what you're going to need. This is an equation I'm going to make you memorize, so you can put this along with the distance formula, midpoint formula. Those are 3 formulas you'll use throughout the whole year. I will not give you these 3 formulas, so make sure you memorize it. If not, put it somewhere where you can get at it pretty quick, inside book cover, somewhere easy to get at. But y2 minus y1 over x2 minus x1 is slope equation. Here it says find the slope of each line. I just left the work up here just to kind of show. But anytime you have a horizontal line like you do here for AB, slope's going to be 0. There's no slope to this line. And if you do the slope formula, you get 7 minus 7 over 3 minus negative 2. You get 0 over 5, and this checks. It has a 0 slope. The other one that students miss quite a bit is if it's a vertical line. If it's a vertical line, your slope's going to be undefined. So this is probably something you want to put in your notes. Again, if it's a horizontal line, it's 0 slopes. If it's a vertical line, it's undefined. If it's a diagonal line, you're always going to have some type of slope, either positive or negative. So if you look at AC here, I can find this by what's the change in rise? Well, it looks like it's 1, 2, 3, 4, 5. So 5 down would make it negative 5. How many am I going over? There's 1, 2, 3, 4, 5, 6. So slope here looks like it's negative 5, 6. And with the work here, it looks like, yep, I'm right. You can go rise over run, or you could do the slope equation. Slope equation doesn't matter which point you call y2 or y1. I could go 2 minus 7 over 4 minus negative 2. That's fine. Or I can go 7 minus 2 over negative 2 minus 4. Either way is going to give you the correct answer. Good note here, fraction with 0 in the denominator is undefined because it is impossible to divide by 0. Again, students miss this all the time. I would definitely take note of this. That way you don't miss this when it comes quiz or test time. This one, I'll have you do this one on your own. So find the slope of CD. You can use rise over run or the slope equation, but go ahead, hit pause here, and work it out on a piece of paper. Hopefully worked it out, not too tough, but here you can see you get negative or positive 1/6 here. You go 1 up and 6 over. If you go from C to D, it looks like what the book did. You go negative 1 down and negative 6 over. So it doesn't matter which way you go, you'll get the same answer. I can go 1 up. I can go 1 up and 6 over, or I can go 1 down, left 6, and you'll get the same thing. Hopefully you got that one right. Shouldn't be too tough to find slope. Here I'll have you do another slope equation on your own. Last one you could use rise over run, but this one's probably best to use the slope formula. Go ahead, hit pause, see if you can get the right slope here. Here you can see the work. It doesn't matter which one you call y2. I could call point J y2 or point K. So one way you get negative 1 minus 1 over 2 minus 3 gives you negative 2 over negative 1, which is a slope of 2. If I switch the order around, then it's 1 minus negative 1, which turns into 2, 1 plus 1, and then 3 minus 2 gives you 1. So either way, you should have got 2 for this one. Here are the 4 possible slopes you can get of any line. A positive slope always goes uphill as x gets bigger. Negative slope's just the opposite. Y gets smaller and smaller as x gets bigger and bigger. Zero slope's always a horizontal line, and undefined for a vertical. One thing the book will mention sometimes is slope and rate of change. Rate of change is going to be something y over something x, which is same as slope, and different labels. So you might see something like miles per gallon, feet per second. All of those are rates of change. And this is a type of problem you'll see with the rate of change. Realize there's 2 points here. Justin's driving from his home to his college dormitory. At 4 o'clock p.m., he's 260 miles. That's a point. And continues on, at 7 o'clock, he's 455 miles from home. That's a point. Here it says, graph the line that represents Justin's distance from home at a given time. Find and interpret the slope of the line. So slope is change of y over change of x. And here you'll see that it's going to be a rate of change. Whatever your y is, that's going to be on top. And whatever your x is, that's going to be on bottom. So here it's going to be miles over hours. And when you calculate it, you get 65. And the book doesn't label the graph here, but it's 65 miles per hour. So here you're figuring out his speed, and more so his average speed. 2 theorems in this section. Parallel line theorem, if 2 non-vertical lines are parallel, if and only if they have the same slope. So they have to say non-vertical because it's undefined. But right at the end, any 2 vertical lines are parallel. Next one, perpendicular. If you multiply the 2 slopes and get -1, they're perpendicular. Another way of saying that is opposite reciprocal. So example of this might be, I'll give you a slope of, say, 3. If I want something parallel to that, it has to have the same slope. If I want something perpendicular to that, it's going to be opposite, so it's +3. Opposite would make it -3. The reciprocal of 3 is 1/3, because I can write 3 as 3 over 1. So reciprocal, you switch top and bottom, now you get 1/3. Now if I multiply 3 times -1/3, I'm going to get the -1 that's mentioned here. And we're going to do these on the next examples. Here the book just reiterates, if a line has a slope of a over b, then the slope perpendicular to that is negative b over a. They're called opposite reciprocals, and this is one way to tell if lines are perpendicular. Or you can multiply the two and get -1. Either way works. Here you have a caution for 4 given points. Might not always determine 2 lines. So graph the lines to make sure the points are not collinear. Here's an example that you'll see. It says graph each pair of lines. I'm not too big if you don't graph them. I'm more interested in the slope. So on your homework, you don't have to graph if it says this. I want to know what the slopes are. It says use the slopes to determine whether they are parallel, perpendicular, or neither. So here you got to find the slope of uv and find the slope of xy. So when the book does it here, I get the slope of uv is 3. The slope of xy is -1/3. If I multiply those, they do give me -1. One is the opposite reciprocal of the other. So these are in fact perpendicular lines. Go ahead and find if these two slopes are parallel, perpendicular, or neither. Go ahead, hit pause, and when you're done, hit play. If you did the slopes correctly, the slope of GH is 1, the slope of IJ is -2. So you got the opposite part, but they're not reciprocals. So here's an example where it's neither. It's not parallel, not perpendicular, so the answer is neither. Same thing as the last one, I'll have you do this one. Find the slopes of CD and EF, compare, and see if they're parallel, perpendicular, or neither. Go ahead, hit pause, and when you're done, hit play. So as you can tell from the graph, these are parallel. They both have a slope of 2. Since the slopes are the same, these two lines are parallel. One other example I want to show, that way you can kind of see most of them here, is perpendicular. Here you got undefined and 0. You just have to realize one's a parallel horizontal line, one's a vertical line. Those are indeed perpendicular. So here, note if you multiply the two, you don't get -1. This is kind of a counterexample, but this is an example of perpendicular lines. So be careful of vertical and horizontal lines. Hopefully this section is not too tough and mostly a review from what you saw in Algebra 1. But main part, slope is rise over run, or y2 minus y1 over x2 minus x1. Two slopes are parallel if they're the same slope, and perpendicular if they're opposite reciprocals, or if you multiply and get -1. You can go ahead and start your homework here. It's page 185, and numbers 2 through 28 even. I'll be back tomorrow, so if you have questions, you can wait, and I'll help you then. And going back to the first part of the slide, what did the green grape say to the purple grape? He said, stop holding your breath and breathe. Hopefully you get it. If not, I'll help you tomorrow. Have a good day. Bye.